Welcome back to the Python 101 series. Here, we will learn the basic Python skills needed to get started with artificial intelligence and machine learning. As usual, timestamps are in the description below. In today's video, we're going to dive into one of the core concepts of programming, if-else statements and logical operators. These are the building blocks for decision-making in your code. As we learned in the first video, Python executes each line of code one by one. But what if we need to skip some lines based on certain conditions? Well, this is where flow control comes in, like an if-else statement. The definition sounds like this. An if-else statement allows you to control the flow of your program by making decisions based on a condition. You're telling your program to execute specific code only if a certain condition is true, and to do something else if it's false. Now, to understand better, let's try a real-life analogy. Think of it like writing a smart weather app. As a developer, you want your app to tell users what to wear based on the temperature. If it's cold, like below 10 degrees Celsius, the app suggests, wear a jacket and a scarf. If it's warm, like above 20 degrees Celsius, it says, t-shirt and sunglasses time. But if the temperature is in between, the app might say, a light sweater should do. Just like this, if-else statements help your code make smart decisions based on conditions. The basic structure of an if-else statement is as follows. The if keyword is used to define the condition that we want to check. The code that follows will execute only if the condition evaluates to true. The else part defines what happens when the condition in the if statement is false. The code after else will run when the condition is false. Python relies on indentation to indicate which block of code belongs to the if statement and which belongs to else. This is different from many programming languages that use curly braces to mark code blocks. If the indentation is wrong, like using inconsistent spaces or mixing spaces with tabs, you'll get an indentation error. Would you like a real example? As usual, we first need to set up a variable. In a more realistic scenario, it would be retrieved through an API or user input. But since we need to walk before we run, we will manually set and change it. So, we set temperature equals to 40 degrees. In our weather app example, we first want to check if the temperature is over 35 degrees, meaning it's risky hot. In this case, we use the greater than operator. If the temperature is greater than 35, then the block of code inside the if statement executes. So, in the indented part, we'll place a print function with a warning message like, it's a hot day, drink plenty of water. When we run the script, the warning message appears because 40 is greater than 35. But what if we change 40 to 35? Oh, nothing happens. Did you spot why? It's because we set temperature equals 35, but the condition checks if the temperature is greater than 35. Since 35 is not greater than 35, the if condition evaluates to false, and the program skips the if block. It then moves to the else statement where nothing is set. So, let's build the else statement too. We add another print function with the message, it's a cool day, wear a jacket. We run it again, and it works. The condition temperature greater than 35 is not checked. Since 35 is equal to 35 and not greater, the program print the else statement, since this is true. It all sounds good in theory. But is it really true? I mean, yes, theoretically it is, but 35 degrees is still a pretty hot day, right? So, what can we do? We could try to find a middle point in the temperature, but in real life, we don't just have risky hot and cool days. No single degree difference will drastically change whether you wear a jacket or face extreme heat. That's where Python provides the perfect solution, adding multiple conditions. We can define multiple blocks of code that execute when different conditions are met. This is done using Elif, short for else if. And the best part? We can add as many else statements as we need. So right after the if statement, we build our new Elif exactly the same way as if. Let's do this. We place the magic word Elif, add the condition, temperature greater than 20, put double points, and in the indented block, we add the print function. Or, in the future, the action we need to take in this case. But for now, we only print it's a warm day. Now the app works like this. If temperature greater 35, the program prints it's extremely hot, so drink a lot of water, and then ends its execution. Next, if the first condition is false, but temperature is still greater than 20, second condition is true, so it prints it's a warm day, and after this ends its execution. Lastly, if both conditions are false, the script navigate further to the last block. So temperature is below 20, it prints it's a cool day. Wear a jacket, and only then ends its execution. We see it's still not entirely true since we don't really wear jackets at 20 degrees, so let's add one more statement. We place again the same magic word Elif. We add the condition, this time temperature greater than 10, so this condition will be true only when the temperature ranges between 11 and 20. In the indented block we place the print function with the message, it's a cool day. A hoodie could be needed. And when all three statements are false, the last block will be executed. Only when temperature is under 10 degrees and a jacket is indeed necessary. You can take some time to experiment with different temperatures to see if the logic works correctly and if any improvements are needed. So far, we've been using the greater than operator to compare the temperature, but there are many more comparison operators that you can use to compare different values. Let's take a look at some of the most common ones and how they work. Equal to. This operator checks if two values are exactly the same. If they are, it returns true. For example, if the temperature is exactly 5 degrees, we can use the equal to operator to see if it matches. So, 5 equal to 5 would be true. This operator can also be used with booleans. If a variable holds a boolean value, you can compare it with true or false using the equal to operator, like is student equals true. However, you can also simplify this check by directly using the variable in the condition, as it will evaluate to true or false automatically.
Not equal to.
This checks if two values are not the same. If they're different, it returns true. For example, if we have a temperature of 5 degrees and we want to check if it's not equal to 3 degrees, we can use the not equal to operator. So, 5 not equal to 3 would be true. Greater than. This operator checks if the value on the left is larger than the one on the right. For instance, if the temperature is 7 degrees and we want to know if it's greater than 3 degrees, we use the greater than operator. So, 7 greater than 3 would be true. Less than. This operator checks if the value on the left is smaller than the one on the right. For example, if the temperature is 4 degrees and we want to check if it's less than 9 degrees, we use the less than operator. So, for less than 9 would be true. Greater than or equal to. This checks if the value on the left is either greater than or equal to the value on the right. If it's 5 degrees and we want to see if it's greater than or equal to 5 degrees, we can use the greater than or equal to operator. So, 5 greater than or equal to 5 would be true. Less than or equal to. This checks if the value on the left is either smaller than or equal to the value on the right. For example, if the temperature is 3 degrees and we want to check if it's less than or equal to 4 degrees, we use the less than or equal to operator. So, 3 less than or equal to 4 would be true. With these comparison operators, we can compare numbers, text, and other values in Python. For example, in our weather app, we might want to check if the temperature is not just greater than 35 degrees, but also if it's exactly 35 degrees. So instead of just using the greater than operator, we could use equal to or greater than or equal to handle different situations more precisely. Now, let's explore how these logical operators work and how you can use them in your code. The AND operator is used when you want both conditions to be true for the code to execute. Imagine you're building a weather app and you want to check if it's hot and sunny. You would only want to go outside if both of those conditions are true. For example, if the temperature is 30 degrees Celsius and the weather is sunny, both conditions are true, so the action will happen. If either one of them is false, for example, it's hot but not sunny, the action won't be executed. The OR operator is used when at least one of the conditions must be true for the code to run. In the weather app example, you might say, if it's hot or sunny, go outside. Even if only one of these conditions is met, the action will still happen. So, if it's hot but not sunny, or if it's sunny but not hot, the code will still run because one of the conditions is true. The not operator reverses the result of a condition. For example, If it's not raining, go for a walk. If the condition is false, if it is raining, not will make it true, and the code will execute. If it's not raining, then the not will turn that condition false, and the code will skip the action. With logical operators, you can combine multiple conditions to create complex rules for your code. They allow you to evaluate several conditions at once and decide what to do based on them. For example, in our weather app, we might use logical operators to handle multiple factors like temperature, sun, and rain. This makes your code more powerful and flexible. Now, we understand if-else statements, but there will be a hard moment in your journey as a new developer when these conditions will not be enough. You will need to check conditions within another condition. But luckily, Van Guido already met this challenge and built us the perfect way to tackle it: nested conditions. Simply put, these are if-else statements inside another if, elif, or else block. This allows us to make more detailed decisions based on multiple factors. The basic structure of a nested condition looks like this. We are already familiar with the if-else structure, but what's new here is that inside the else condition, we indent another if, elif, and else block. So, in this script, the program will first check the first if statement. If it's true, it ignores the rest of the code and ends there. If it's false, the program moves into the else block, and here it starts checking the conditions again.
First, it checks the if statement again.
If true, it ends there. If false, it moves to the elif, checks that, and if that's also false, it goes to the final else block. Before we dive into our example, it's important to remember that nested conditions can appear not just inside the else block, as we'll see in our example, but also inside an if or elif block. It's a flexible tool that lets you build decision trees at any level of your logic. For our current example, we'll focus on using nested conditions inside the else block because it fits the scenario, but keep in mind that you can apply this pattern anywhere in your code. To better understand, I created an old-fashioned password checker. Of course, in real life, we would use more advanced techniques and achieve the same result in less than 5 lines, but this example should help you learn and understand the concepts more deeply. By the way, pay close attention because by the end of the video, you will get multiple exercises like this to solve. Solving them will help you understand the syntax better, and your brain will start developing problem-solving skills, which are crucial for every developer. Now, let's dive into the exercise. In this example, we'll build a script that checks if the password is secure and hard enough. We'll start by taking an input from the user and saving it in the password variable. Do you remember how we do this? Choose the variable name, password, followed by the equal sign, and invoke our beloved input function. We should also add a message, so the user knows what to provide. Please enter your password to check. Now that we've saved the password, we can use the variable in our conditions. The first scenario we'll check is whether the password is shorter than 8 characters. If it is, we print, password is too weak, choose one with at least 8 characters. But which operator should we use for this check? We need to know the length of the password, so we'll use a built-in special function called len, followed by parentheses, because it's a function, and inside the parentheses, we'll put the variable we want to check, password in this case. What this function does is calculate the length of the string, each character in the password. In this case, we'll use the less than operator because if the password is less than 8 characters, we want to close the script and ask the user to try again. But if it's longer than 8 characters, we'll move to the else block and check other things, like if the password contains numbers or if it has lowercase letters. In the else statement, as we see, we need to build another if statement. Since the password in this scope will always be longer than 8 characters, we now need to check if it contains any number. To do this, we will use a special method this time, isdigit. Do you remember how the method syntax works? For the if condition, we place the password followed by a dot, and then the method isdigit. Don't forget the parentheses. It looks a bit different, but this is it. This is our condition. I told you Python is smart. Here's how it works. Since we don't put any operator here, it only checks if the variable contains digits. Actually, it checks if the password is made up entirely of digits. So if your password is something like 1234567 it will activate this if statement. But if the password also contains letters, the statement will be false, and it will move on to the Elif block. In the Elif block, we want to check if the password contains both uppercase and lowercase letters. For this, we will use a simple trick. We'll call the lower method and compare this to the original password. If both are the same, it means the password only contains lowercase letters, but if it's false, this block will also be false, and the program will move on to our desired block, the else statement. How do we do this? We first call the variable add the and look for the lower method. I'm sure you remember this from the exercises you've done. Now, we use the equal operator, double equals, don't forget. We compare the result against the original password. And that's it. Feel free to test the script with different passwords. Also, don't worry, the main skeleton will be displayed in your exercises, and you can redo this process once more. You ready to tackle the exercises I've planned for you? It will take a little time, and you may run into some errors along the way, but this is the right way to learn programming. Watching tutorials alone won't take you far, but practicing will. So, whenever you're ready, grab your cup of coffee or tea, grab the exercises, and get started. In the description below, you have 2 methods to get the exercises. First method, navigate to my GitHub link, click on Download, unzip the archive, and then simply drag and drop the entire folder into VS Code. Second method, join my Discord server, head to the practice section, and download the zip file. Again, unzip it and drag and drop the folder into VS Code. In the Explorer tab, which you can open and close by clicking the first icon, you'll find a folder called Day, followed by the learning day we are in. Inside this folder, there are 3 subfolders. The first one is called Exercises, and I recommend you get started with this right away. The second folder is called Recap, and I suggest you wait until tomorrow to go through it. Giving your brain some time to process everything you've learned today will help reinforce your understanding. In fact, studies show that sleep plays a huge role in consolidating new information, so sleeping on it could help you recall the concepts more easily the next day. The third folder is for after a short break. Take a day off before tackling the next set of exercises. This will give your mind a chance to recharge and come back with fresh energy. Taking breaks in between learning sessions is really beneficial for long-term retention and keeping motivation high. Don't worry, when you get back, the exercises will be a little more challenging and will need a bit more research, but I'm confident you'll do great. You'll also have lots of hints along the way to guide you through. And remember, if you ever need help, don't hesitate to reach out to me in the Discord channel. I'm always happy to support you as you progress.